Hi guys, welcome to the YouTube channel. In today's video, we are going to see how Java is platform independent in a practical way. So before getting into deep, we can see what is compiler and interpreter first, okay, in a low level manner. So let's say if you are using a compiler based language, which is C, C++ and etc. Code is going to be compiled completely for checking for any syntax error or any exception runtime errors and everything, and it's going to throw in an error all of this sudden if there is an error in your code. But when it comes to interpreter language like Python use interpreter language, so which will be executed line by line. So if you have an error in line number 9, so till line number 8 it will be executed, then the line number 9 will be thrown. So this is the case for runtime errors, right? So Java attains this particular platform independence using both compiler and the interpreter. Okay, let's see how it exactly doing it. Okay, so let's say I'm going to create a main.java file at the initial. So this particular Java will be converted to a bytecode, right? So usually in compiler based languages like C, C++, they will convert the code directly to the machine language, which makes them platform dependent. So each platform have their own machine language. So they attain a platform dependency stage. In Java, we don't convert the code directly to the machine language. Instead, we just convert this particular code into bytecode. So bytecode is nothing but it will be in the extension of class. So once this bytecode is created, this particular bytecode can be run in multiple platforms. Let's say if you are writing a program, like you are writing a calculator application, you can run it in macOS, Windows and Linux in a multiple platform without replicating the code again and again for each platform. You can write one single code. With a single code, you can execute the calculator between all the platforms, right? So how this particular bytecode is converted to machine language? This particular bytecode is converted to machine language using the help of JVM, which is Java Virtual Machine. Okay, so this will be helping us to convert our bytecode into machine language. So this particular JVM is platform dependent. Let's say if you are using Windows, right? If you are using Windows, if you are using a Linux, and if you also have Mac OS, okay. So you have separate JVM for Mac OS. You will be having separate JVM for Windows, and you will be having a separate JVM for Linux. So you can see each platform demands its own JVM, which makes it platform dependent, a particular JVM, right? So this particular bytecode is written once, and it is like interpreted among all the platforms. So to convert this main.java to this particular bytecode, we will be using compiler, right? So once it is compiled to bytecode, they will be using JVM. JVM internally you will be acting as an interpreter, right? So this is how Java uses both compiler and interpreter to work along across all the platforms. Okay, let's take a live example, like live demo, how this exactly work. Okay, I'm going to create a Java file right now in an empty directory. So let me create a new text document and just name it as main.txt, and just changing the extension from txt to Java. Yeah, so I have created a Java file, but inside this file there is no code written right now. So what we can do is just open with a notepad, and I'm going to write a piece of code in this. So yeah, I have done writing my hello world program in a notepad file inside the Java, right? So I'm just saving this particular file. So as we discuss, what we are going to do is we are going to convert this particular Java file into bytecode using the compiler. So we have Java C compiler. So just open this particular directory in command prompt, and you check for the files that are foundable in your compiler, like this. You just check for the files what are present in this particular directory. So now you can see there is only one file, right? Main.java. So what we are going to do is we are going to compile this main.java using Java C compiler. So once your code is error free, then it will be compiled to bytecode as discussed. So you can see there is another file have been created right in this directory, which is main.class. So this particular Java file is converted to main.class, which is nothing but a bytecode. Now this particular bytecode is can achieve platform independence using platform dependent JVMs. So currently I'm using Windows, so I have my own JVM respective to my particular platform, right? So I can execute this bytecode so that okay, I can use JVM to convert this bytecode to a machine language. So how we can do is using in an interpreter. So just go and type Java, which will invoke your JVM. So just give main. So this particular main will be collected from the class, right? So this class will be directly converted to, I got the output, right? So this particular Java code is converted to a bytecode, and this particular bytecode is converted to the machine language respective to the platform's JVM. So this is how Java attains platform independent. So thank you guys. If you have any queries regarding this, please feel free to post in the comments. So see you in the next video. Bye.